Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today I wanted to share with you something that really intrigued me. Imagine watching a live 4K video from the moon. No grainy footage like Apollo.
It's one small step for man, one giant leap for mankind.
No delayed telemetry. I mean smooth, high quality video from deep space. Well, that's exactly what the Artemis II mission is doing right now. And the amazing thing is that they're not using radio waves, but they're using lasers. In this video, we're going to break down how laser communication works, how NASA is leveraging laser wireless communication for its moon missions, and why this changes everything, not just for space, but for networking as a whole. Let's set the stage. Artemis II is the first crewed mission to the moon since 1972. It's a 10-day lunar flyby mission with 4 astronauts. And this is a critical step towards returning humans to the moon. But beyond the mission itself, this is also a technology demonstration mission. And one of the most important technologies that's being tested is wireless laser communication. Now, until now, space communication had relied on radio frequencies, or RF. And RF has limitations. It has limited bandwidth, it has a congested spectrum here on Earth, and it delivers lower data rates over longer distances due to what is known as free space path loss, due to beam divergence. Laser light doesn't behave in the same way. It has much less signal loss over space due to a much smaller beam divergence. NASA's wireless laser solution is called O2O, Orion Artemis II Optical Communications. And here's what makes it revolutionary. It uses infrared laser beams instead of radio waves and can achieve speeds of up to 260 megabits per second from the moon. That means that it can easily support multiple 4K video streams, real-time high-capacity data exchange, and extremely high-resolution imagery. That speed is comparable to high-speed internet connectivity at your home, school, or place of business, depending on where you live in the world, of course. But remember, these speeds are being offered from the moon. Earthbound laser communication systems have already achieved speeds in excess of 300 gigabits per second. Yes, that's right, 300 gigabits per second. That's over 100 times faster than the moon data link. And things are getting better and even faster. One of the major benefits of this type of link is the fact that it is immune to interference from other signals, and it uses about half the energy of Wi-Fi. With continually evolving compact chip scale platforms integrating custom beam shaping optics, speeds, ease of deployment, and costs are all improving drastically for this technology. But despite its exceptional progress, laser communication isn't perfect. It still has some drawbacks. For long-distance communications, like communications with the Artemis II crew, you need to have extremely accurate aiming. The laser pointing to the Artemis spacecraft and back must be highly accurate, otherwise you lose connectivity altogether. The accuracy must be so precise at these distances that the aiming mechanisms can be as expensive as the communication equipment itself. Secondly, for earthbound systems, laser light is subject to atmospheric interference. So clouds, humidity, fog, and rain can all attenuate the laser signal to a high degree. Because of this, for its purposes, NASA maintains a radio communication backup to ensure communication is not lost with the Artemis crew. Now let's zoom out a bit. This is not just about space, it's about the future of wireless communication. Laser-based wireless, officially called Free Space Optical Communications, or FSO, is already being explored for satellite internet, inter-data center links, high-speed urban connectivity, and many other applications. And the advantages? We have fiber-like speeds without the need for the actual fiber infrastructure. We have no spectrum licensing because we're allowed to shine laser light in various directions. And it provides us with extremely low latency. So if you're a network engineer or involved with telecom, this is really huge because the same principles apply to this technology as to all telecom and networking technologies. Laser wireless communications offer point-to-point links with bandwidth optimization and a high level of signal integrity, but should always be supplemented with an RF backup. This is basically networking, but at a planetary scale. So next time you hear we're streaming 4K video from the moon, it's literally true. But as a network engineer, or a network enthusiast, or both, it's important to understand what's behind it. Precision optics, laser communication, and next generation networking concepts. If you enjoy breaking down complex technologies like this, then please subscribe to the channel, because here telecom and networking technologies are simply explained. Before I end off, let me ask you this. Do you think laser communication could eventually replace RF, even here on Earth? Or will it always be a complementary technology? Drop your thoughts in the comments below. I'd be happy to hear what you have to say and to continue the conversation. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.